video, we'll quickly go through how to transcribe and translate a DNA template. So the first step is I have my DNA template here. And then I'm going to use that in order to make the mRNA. So remember, RNA polymerase is going to attach to the DNA strand at the promoter site. And remember, there's some transcription factors that are involved that kind of help turn on transcription. And then RNA polymerase can actually unzip the DNA where it's at and transcribe until it gets to that terminating sequence, and then it will just fall off. So it's only going to transcribe that gene until it reaches that ending terminating sequence, and then it'll stop. So remember, it's adding RNA bases, so ribonucleic acids. The only difference is that it's missing a hydroxide group. So instead of, it's a little bit different than, deoxyribose is missing a hydroxide group, whereas RNA has that hydroxide group. So everything else is the same. That's really the only reason it has a different name, is because the structure is just a little bit different. So RNA polymerase is going to come in and add my RNA base pairs. And remember, the main difference here, really the only difference, is that there is no thymine, there is no T, and instead I have a U. So I'm just adding in my complementary base pairs, and we can see I've added a U everywhere, opposite an A, because since I don't have a T, I can't have any thymine. So now that I have my mRNA transcript, right? So this is what we call a transcript. Now I'm going to come in with a tRNA, and it's going to bring in this amino acid. Okay, so really, we have our codon here. So I'll label a few things. So here's your codon. This is an anti-codon, meaning it's just the opposite of the codon. So when I go through and I start labeling out my anti-codons, again, they're going to be the exact opposite. Oh, whoops. Losing my mind here. The exact opposite, here we go, of the mRNA. Okay, so I have GUA. So now this is the anticodon. So that only purpose really for the anticodon is so that it can bind to the codon. So it can attach via those hydrogen bonds to the codon or the mRNA. Okay, so with it, it's going to bring an amino acid. So how do I know what amino acid it's going to bring? We're going to look at our codon chart, okay, and we go based on the mRNA, right? So this is one mistake I saw being made several times. So my codon, my mRNA is CAU. So I'm going to come over here. I'm going to find C, A, and then U, okay? And so that means my amino acid is HIS, okay? So now I'm going to go do that again. So UAU, right? I'm going to write my complementary tRNA strand, right? But I'm using my codon, the mRNA, to find my amino acid. So UAU. So I'm going up here. I'll erase all this. I'm going for UAU. So UAU. So there's tyrosine. TYR. Okay, and then I'll just keep going down the line in sets of 3. So this is C, G, A. I'm going to use GCU to find my GCU alanine. Okay, so I'm just going by sets of 3, using my mRNA codon to determine my amino acid. Okay, so we really don't use the tRNA at all. It's only there just so that it can bind to the mRNA to bring those amino acids. And so then as it's going along, these little amino acids are being tied together with what we call peptide bonds. Okay, so inside the ribosome, where this is occurring, our amino acids are just being kind of stuck together, bonded together via peptide bonds. Okay, so now then you get that whole chain of amino acids, which makes your protein, right? When we were talking about macromolecules, our amino acids are our monomers, our individual pieces, and they kind of conform together to make our folded protein that serves some function, some purpose. Okay, so hopefully that helped. Just kind of understand the basis. You will have to do this on the quiz and the test, so just make sure you're comfortable going through and matching up the amino acids with the mRNA.